Hi all, welcome to the next session for Month-End Training. The problem statement is identification of online fake content. That is problem statement ID number FCD-09. Now, today we'll be discussing a lot of things related to SA, NLPs, sentiment analysis, NLPs, this fake content, okay? So we have a very less time with this, but a lot of content to cover. So we'll be straightly getting it to started. Okay, so let's just get started with this. What is fake content? Now, as I say, when I talk about fake contents, fake poses two threats, right? We'll be talking about it one by one about the threats. Okay, first let's understand about the scenario of this fake content. Okay, so we live in a world of major technological breakthroughs, right? But sometimes advancements remain beyond our grasp. So we know that today computers are able to create artificial entities like human faces, and that their differences from real ones often are invisible to humans. So as a data analytics expert and being a machine learning engineer, I believe these technological things could represent global threats ranging from different kind of sabotage to political games. Now, videos can be fabricated so that it is impossible to immediately separate truth from the lies. Just imagine the damage that technology these cases, fake content cases I'm talking about, these cases could be making forward in the coming up futures. Okay. So over and over again, like news about how technology can fake the faces of celebrities in videos keep coming. A lot of things are there related to contents. We see fake news contents, fake videos, fake images, artificially generated deepfake contents. A lot of things are there. So we need to talk about all those things in very much detail, and then we'll be moving forward with the codes. And I'll show you that with the help of the SA and the NLPs, the emotions and everything, how we can identify whether a content is a fake or not. So we'll be deploying a machine learning model over there, and we'll see the accuracy, which is coming nearly around to 90%. Okay. So let me brief once more to you about your problem statement, okay, which is under the fake content detection. So your problem statement says that false or misleading information is sometimes intentionally generated and propagated by the hostile actors as news of various malified intentions, such as to cause reputation damage, create panic, unrest, and suppress real news. So your primary objective of this problem statement is to identify fake and misleading content published on social media platforms, blogs, forums, news, websites, etc. Right? Okay. So this is like what we will be dealing with these fake content things. Okay. Yeah. Moving forward. So, take as another example, a recent incident where malefactors using a fake voice tricked a company's subordinate into transferring over $240,000 to their account. So this is isolated case, but think of what could be happening without our knowledge. The problem of detecting these fake cases is not new, but the advent of generative adversarial networks, or we say it as GAN, in 2014 marked a milestone in the detection of next generated fakes. Okay, so like these fakes actually poses two kind of threats basically. So we'll talk about what are threats. Okay, there are threats. Now, what kind of threats is being done, right? In fact, like I believe that fake is what I'm showing you there in the PPT. These poses like two threats. So the first threat is the creation of fake entity itself. That means bad actors could create fictitious accounts on social networks that would display fake activities, right? The second threat is, you can say, the fake content that an existing entity appears to produce. When we say it appears to produce, here a character might create content that discredits this person or extort money under the guise of this character by fogging their identity, voice, or writing styles according to the writing styles, right? So we'll talk much on this, how these fakes are created actually. It is not difficult to create fake entities actually. Free, like publicly available tools allow people to create new fakes on non-existent peoples, or like face swap using existing photos. So creating content on behalf of a fake person requires an approach called transfer learning. Okay. So how we can confront this problem? This is like what we need to discuss more precisely. When fakes begin to appear, researchers begin to search for ways to determine whether a given object is a fake video, image, or audio, or a text file. Okay, so for this, they invented several approaches. The first way to detect fakes is called object features. Right? Object features. Now, you can see this approach is based on selecting the features of an object. If you take a picture of a face, and you can try to analyze the existence of certain artifacts in places where you don't want to have them. Okay, the places where you don't want them to be exactly. An algorithm that creates a fake typically basically fails in pictures at the intersections of hair and body and leaves visible artifacts there. So actually, people often blink less often in a fake videos than in the real ones. So the artifacts of fake videos include slow eye blinking and lack of blinking. Right? These are like some of the approaches, or you can say kinds to identify. The second way to detect fake is through format features. All the features in a piece of content relate to a particular format. So you can analyze these features of images such as smoothness, like to detect these fakes. So fake images tend to have smoother textures. Okay. All right. Sorry. The next way, if we talk about, is to implement deep neural networks to detect the faces and even the fake newses. Okay. So there is a large data set of fake and non-fake images available. You can train a model to differentiate these images if you are working on fake images only, not in a fake news content, right? Depends, like content could be anything. It can be a news, it can be an image, it can be a video, anything in any format. If it is a fake, you need to identify whether it is fake or not, a non-fake or fake, right? You don't come up with some special features, but rather rely on the fact that the model will learn and will be able to see the difference between the fakes and non-fakes that you have to create. Okay. Apart from all these methods, there is one more method, right, which is called as neuron monitoring. Okay. The analysis takes place at a deeper level. You look at the neurons and the layers of the network that are activated in real and fake images and select algorithms to identify fake images using this data. Right. So again, that is in the terms of GA, and as I said, I discussed previous, right? These are currently the main strategies for detecting the fakes. Meanwhile, technology does not stand still. It may be able to bypass almost all defenses from the first and second categories as the quality of GA and generators. Okay, as the quality, like if it grows, I expect that the third category will soon no longer be relevant, right? So results are actually unclear. We are in a stack of mind that will technology go so far as to generate fake content? That is, unless we embed a signature or record a blockchain to prove its authenticity. Although this may be the only option in future, but technologies should still develop more accurate methods to detecting for fakes now. Okay, so it's a constant sword and shield fight that will continue. Okay. Another distinct issue is who is responsible for creation and distribution of fake materials. That is one of the problem statement. The tracing of social media posts, right? This is again a big issue, that is who is responsible for creation and distribution of these fake materials, as well as whether the owners of global platforms like YouTube, Facebook, Instagram, Twitter, now where have these obligations to detect fake content on their platforms. So this is a global problem, and we should deal it with right now. Or if you are solving this idea, it's very good. Just try to grab the things accordingly. Okay, so we'll be going through some of the terms like what is SA. First of all, sentiment analysis, we need to understand that. Then we'll be going with the importance of sentiment analysis and the methods for the sentiment analysis. Okay, fine. Let's proceed and understand about this sentiment analysis. Now, with this essay or sentiment analysis, I'll first like to discuss more precisely on this. As we have a very less time, we'll be trying to go as quick as possible. Okay, so we are all surrounded by devices that run on internet. Previously, it was just the computers, but now we have web on mobiles and tablets that are handy. So in a way, the technology has not benefited the business and made our lives easier, but also it has enriched our online experiences. It has become a platform where people spend a lot of time, seek knowledge, exchange ideas, and even shop. Right? We all do online shoppings relatively on different websites. Okay. So for example, when we want to make a purchase online or offline, what we do initially, we browse through different websites and forums to see if people are talking about it. That is called reviews kind of thing. Okay. So we check out a few online stores that sell what we are actually looking for. We read through the reviews and comments that many people have written or expressed about the product and the online stores. Only after going through a good number of reviews, we decide whether to make a purchase or not. Right? So sentiment analysis can be defined as a systematic analysis of online expressions, which is this particular essay is greatly used in Python, R, and is an open source tool for the statistical analysis. Okay, so I'm going to perform the important task for essay and visual representation of the analysis. This is like what we deal with the sentiment analysis. Now, why do we need essay? Why the sentiment analysis is important? So most purchase done, okay, or most purchases, what we decide. So we can say that most purchase decisions in the virtual world are made after going through what influential reviewers and peers have to say about the product or the service. So you go with the reviews or the comments of other buyers, okay, and then you decide whether you need to buy this product or not. So this is the reason why the companies are now forced to see and analyze what people are talking about them on the web. From the company's perspective, the reviews and comments become very crucial. Therefore, analyzing the comments and reviews is something that an organization cannot afford to miss, right? Let's talk about Amazon. Let's talk about Flipkart. Okay, let's talk about any shopping website, any even edtech companies, any kind of companies, right? Or even when you go to eat something in a restaurant, right? Everyone takes a feedback. Everyone takes a review of their product. right? So that is important for the upcoming customers, right? So when we talk about this, like comments and reviews, so what are these comments and or the reviews like which are collectively collected, and what are these called as, like why we collect now? Okay, so these comments, opinions, and the reviews are actually known as the sentiment data, and the task of identifying if the comments and the reviews are positive or negative, it's called the sentiment data analysis, or we say simply as sentiment analysis. That is basically you are identifying that the comment or the reviews are positive, negative. That is it a good sentence or a bad one? Okay, that means if the customer enjoyed the product or liked the product or did not like it. That's it. Okay. There is a math behind this sentiment analysis, what we would be discussing. Okay. The math behind the sentiment analysis, because it's not very simple to do a essay, but yeah, you have a lot of things to only research. Like in my previous or past two sessions, I have used a lot of codes. In the upcoming two sessions also, I'll be using a lot of codes instead of the theoretical things. But this topic, like fake content, identifying the fakes. So it is all about, like theoretical concepts to talk about, to find the ways and a lot of things, to find the features. You need first to understand how it works. After it, I have made a code where you will be just going and understanding how it is executing. Okay. So simply reading a post will let you identify whether the author had a positive stance or a negative stance on the topic. But if you are well versed in the language, however, a computer has no concept of naturally spoken language. NSL. There are NLPs, we say it as NSL, naturally spoken languages. So we need to break down this problem into mathematics, the language of computer, we say. It cannot simply deduce whether something contains joy, frustrations, anger, or otherwise, like without any context of what those keywords or what those words means. The sentiment analysis solves this problem by using NLP, which is called as natural language processing. Okay, basically, like it recognizes the necessary keywords and the phrases within a document or a content. That would be better to say, because a problem statement says fake content detection. Okay, so phrases within a document you will be identifying, which will eventually help the algorithm to classify the emotional state of the document. Okay, like the data scientists and programmers, analysts write applications which feed the documents into an algorithm and store the result in a way which is useful for the clients to use and then to understand it. Right? So keyword spotting is one of the most important and the simplest techniques which are leveraged widely by the SA algorithms. The fed input document I'm talking about, like the fed input document is then thoroughly, you can say, scanned for obviously positive and negative words like sad, happy, disappoint, great, satisfied, not satisfied. So all these are actually what? These are sentiments, right? Your feelings kind of thing you say there or write in your reviews that it was a very bad experience for this product. Now, there are several lines, several statements for any kind of thing that call actually has positive, negative strings to say. Yeah? I'm happy because I'm learning NLP. I'm sad I'm not learning NLP. These are what? These are sentences, right? Which have a positive note, a negative note, no, to understand how it is actually expressed. Okay. So there are a number of SA algorithms. not only one, right? So each has a different libraries of words and phrases uh, for which they score as positive, negative, neutrals. Okay, these libraries, like if you are writing a sentence, I did not enjoy the party, but the scenario or the scenery was very good. So you have even written a bad line and also a good line. A positive and a negative string combined, that's called a neutral, right? So you need to identify first and what exactly that sentence is. And mostly you also use the technique of AI, which is called as fuzzy logic. You don't have any positive there, any negative there. So what is this? So that is PC has to be. Okay, fine. All right. So, like, consider a text. The service, I am saying a text, right? So, consider this as for your example. Okay. Let's say I'm saying the service was horrible, but the ambience was awesome. Now, the sentiment is more complex here, as same as I said the previous one about the party, right? So, this sentiment is more complex than a basic algorithm, and it can take into account like it contains both positive and negative emotions. So for such cases, more advanced algorithms were devised which break the sentence on encountering the word but or any constitutive conjunctions to identify whether this is a positive or a negative or coming in a neutral. Okay, so there are a lot of ways for this. So no machine algorithm can achieve a perfect accuracy of 100% in this particular thing, like essay I'm talking about. Okay, and there is no different due to complexities of NLP or natural language. Most of the sentiment analysis algorithms are only 80% accurate at best. If you are 80% accurate in SA, you are at the best level there. Okay. Now, let's just talk about what are the methods to analyze sentiment data. I think I need to go in the next slide somewhere. Pictures, yeah. So you can see sentiment analysis have an approach, that different methods to analyze it, like machine learning approach, lexicon based approach, then dividing in SL, supervised, unsupervised, coming in lexicon, giving it to a dictionary based approach or a corpus based approach. Let me talk about it one by one. We annotate it. Yeah. Now let's just say if I'm just going with the document level of sentiment analysis, I have to just make you clarify things. So opinions are usually subjective expressions. No, opinions, I'm saying the reviews and comments only. Okay. Those are subjective expressions that describe people's sentiments, okay, feelings towards an entity or an event, anything. So many blogs or forums allows people to express their opinion in form of reviews and comments when called as opinions. So when opinions are expressed in form of reviews instead of a simple yes or no, identifying the actual emotions need subjective analysis of the words what are used in the reviews. Okay. So with the next, once again. Yeah. So within it's like in a document level sentiment analysis, each document focus on a single entity or event that contains options or opinions from a single opinion holders. Okay. Now, let's say for an example, I bought a new phone a few days ago. It's a nice phone, though it is a little big. Okay. The touch screen is good. The voice clarity is better. I simply love the phone. Now, this is a sentence. What do you need to understand? machine need to understand. So considering the words or the phrases used in this review sentence, he'll say the sentence is nice, good, better, what it is, right? So at sentence based level of essay, you start giving stars or ratings to positives or negative as like 4 stars, 5 stars, 1 star, 2 stars. Those are like on a sentence based uh, essay or reviews. Then we have aspect based essay. There the document level and sentence level works well when they refer to a single entity. Okay. Then we have a comparative sentiment analysis. All these are coming inside this one chain only for the S. Okay. Then we have sentiment lexicon acquisition. This one, what we are looking in here. Okay. This sentiment analysis method, I think everyone knows about the supervised and the unsupervised, and then probably all the values over there coming in. Okay. So this would be easy to now this would be the other one to understand. And okay. And let's see what we get. So in the lexicon based approach, the sentiment analysis method here uses a list of words and expressions used to express people's subjective feelings and sentiments for opinions. For example, let's take a sentence. Let's say car X is better than car Y. Okay. So you are approaching it with the 3 different methods: manual approach, dictionary approach, corpus based approach. These things. Now, so a manual approach is not feasible. It is very time consuming. So we don't use that. That's why I've mentioned here too, dictionary and corpus. A dictionary based approach uses word net to find suitable. I'll write if I can write it here. Words okay. It has got a bit bad, but it's okay. So it is word net. Okay, so oh sorry. I was having one method here to just simply write. It's word net. Okay, it is better. Next. So you like in the dictionary based approach, you use word this there is an approach called as word net. So you use this to find suitable words of sentiment for to carry out the analysis. Now, when we come to the corpus based approach, it is used to create domain specific sentiment lexicon to carry out the analysis. So once the corpus is pre-processed, the data pre-processing, I guess everyone knows, right? The next stride is to extract the values or the features from a list of sentences. The pre-processed list of words are hence need to be converted into numerical values. So this can be done in various ways. Okay, positive strings, negative strings, having values. You are converting into a sum of values there, like how many positive words, how many negative words, going it through. Okay, so that is like how you can analyze sentiment data. All right. So now let's just move on. So I have written a document level sentiment analysis, sentence level sentiment analysis, aspect based essay, comparative based essay, sentiment lexicon acquisition, manual approach, as I said, is not very feasible. Then we have a dictionary based approach and a corpus based approach. Okay, corpus is actually like, as I said, is used for like calculating the number of values we are having in and then moving forward accordingly to it. Okay, so let me now share you my notebook, and we'll be moving forward with the code now to understand it more precisely. Okay. So we'll be moving to the code now. We share it. There's the brave moment. Yeah. Well, I guess you can see it. Okay, the particular content, what it has been given there in the problem statement. Okay, so do we have any data sets associated till now? It's not there, so it's okay. No problems with that. We have two particular codes I have created with some fake datas and original datas, and that is things. Okay, I'll walk you through some of the things there, right? So this is a data set where I'm importing what I have imported: pandas, numpy, seaborn, matplotlib for like plotting of the confusion matrix, then for seaborn for calculating the values. A good plot there basically. Numpy for taking up the mathematical features, pandas for dealing up with the data sets. Then I'm creating model. So for that I have used sklearn.model selection. Like if you will be needing to train and test your data, so that would be a train test select. Okay, sorry, split. Then accuracy scores and the classification report, and that and string of basics. Okay, fine. So this is a fake CSV and a true CSV file we are taking, and then just take it out the head of this file. So you're getting a title, the text, what is written, the subject, and a date. So first of all, like with this head, if I try to retrieve the first value, as you can see, the head, I guess, head is okay. So now I'll try this, that I'll take a fake value here, sorry, fake row, that is the first one. It will be a fake content or not, right? Because it's a complete fake data set. So we are not specifying that it is a fake, it is not a fake content, right? I would just be going it through that. Okay. All right. So now with this data, I'll be taking the first one. So you get the title, you get a text, subject, date, and a class. So let's say if you have a title, you print the title. The title is Donald Trump sends out embarrassing New Year's Eve message. This is disturbing. This is a fake content, a fake news. That's why it is there in the fake CSV file, obviously. Okay. So what I'll do is I'll also try to see the text there. So the text is quite big, as you can see, the complete news file it is, and a text has been given. Okay. So a Twitter file, basically these data of the news detections and all are basically taken from Twitter every time. So most of the times. Okay. So that is why, like many a time you might see somewhere Twitter written also. File zoom in and check once. Yeah. So see, like pic.twitter.com slash this particular thing. If I let me see if I can execute this line, I can show you. Can it run now? Let's see, will it run? So it's Daniel Dale 8, right? And you can now see there is, one second, I'm showing you this. So Donald Trump just could not wish all Americans a Happy New Year and leave it at that. So as we can just like have a review with this. You see here, Trump has directed messages to his enemies and haters for news year's Easter. Now this, you need to identify it's a fake content or not a fake content. Okay, right? So, like as a country rapidly grows stronger and smarter, I wish to all my friends, supporters, enemy, haters, and even the dishonest fake media a happy and healthy new year will be great for America. Okay, so this content is a fake content or not, you need to identify. So with this ID or things like as you can see over there, sometimes this pics has also been given that which picture it is of what content. You can even retrieve the data. So it is having a fake data there. That means the title of this was Donald Trump sends out an embarrassing New Year's Eve message. Okay. If we take some data from 15, 16 value. Okay, it's again Tone Deep Trump. Congrats, Rep Scalise on losing weight after you almost died. If we take text of this, let's see the news. So this is again, do we have any sort of pictures over there with this? No. Okay, fine. We can just have a title, Google it, and you would be getting some sort of results for that if it is a fake content or a original content, right? You may get reviews on there as well, but you need to identify here a fake and a real content. Okay, next. So let's see the heads. All right. This is true values. Okay, true values things. So we are inserting a column called as class for the target feature. Okay, like we would be making it 0 or 1. So df of fake of class would be 0 and df of fake of class, true of class would be 1. So if we check the shape, there we have 23,481 cases for fake values and 21,417 original news. Okay. So what we are doing is removing the last 10 rows for manual testing. Okay. See, removing up some last 10 rows for the manual testing. Okay. From the tail, basically, because tail of 10, like it's the last 10 element. So after doing this, like we are getting the shape 23,471 and 21,407. See, 481, 417, it's 471 and 407 plus 5. Now, we are making the fake manual testing of class equals 0 and true testing class equals to 1. And let's just check the help. So we have a title, text, subject, the date on which the content was done, and the class over there also. Because like things was there. Okay. We are having a class. So we need to add it here for the choose. Okay. So class 0, class 1. Now we will be exporting it to a CSV format so that we can load it the other time and then we'll work it accordingly. Okay. Next, what we are doing is now merging the true and the fake data frames. So it's df fake and df2 are being added. Okay. And like simply are checking up the column names. So once we have checked like title, text, subject, date, and class, we'll try to remove columns which are not required, obviously. Right. The title, subject, date, it is removing. Okay. And it's dropping, you can say. And you're checking whether any null objects or any null values are there or not. So text and class is not having any null values. Now, this is a text and this is a class. Whether this text is a fake content or a fake text or a correct text. Okay. Now, what you're doing, resetting the values. Okay. Index values to 0, 1, 2, 3 as we have done the shuffling. After the shuffling has been done, we are resetting the index value so as there should be no orderness while training. Okay. Then what we are doing is creating a function to process the text values. So word of text and like things would be executed. Now what we are doing is defining dependent and independent variables, because when we are going for machine learning, we require some dependent and independent variables. Okay. So we are splitting it, as you can see, like train, test, and split function, as I said, that we would be using it and that we are using for training and splitting the data set accordingly. So we are splitting the X and Y values because that is again having a complete data set, right? Which is having the values which are like these are the values combined of a fake and a real value, a real news. Okay. I will convert these text to vectors. Logistic regression will be applied. That is working on a sigmoid function, if you know, right? A sigma graph, which is the discrete algorithm, right? So what we'll do is we'll write pred of LR. Simply, what we'll first do X train and X. See, vectorizations have been done, right? Because from the feature, what all the features you'll be getting it will have to vectorize it first. Okay. So this is a process for the vectorization, you know, right? And then we would be making a logistic regression model and fitting the values of the X train and the Y train, what we have written. Okay. So we'll be fitting it. After fitting, we'll try to predict the features, okay, based on the X text values. Once predicted, we'll check the LR score and you can see like it's 0.9877. That means 98% of accuracy in the model. And when we see a report of it, you are getting the precisions recall F1 scores accordingly. Okay. When we come to the another algorithm, that is decision tree algorithm. Okay. So from in the decision tree algorithm, right, the classification you say, you'll be importing from sklearn.tree, simple, imported it, executed the values, fitted the values, executed it, predict again the x text and again 0.9964. Here it was 0.98. So 99% of accuracy. See, now these things are not very much accurate. When I say even if we are getting a 98%, 99% of accuracy, it is not necessary that every time your content would be correct. Okay. So we are adding gradient booster classifier now here to understand it more better. So in the gradient booster classifier also, we are getting a score of 99%, 99.5% you can say. Then for a random forest classifier, we are using 99.0. So for all these, if we just print like the outputs there, even with the logistic regression predict, DT predict, GBC predict, RFC, random forest and all, if you are using this to predict the values, no, you will be trying to give news. Okay, one news will be given. So I have entered one news over there, this news, and I'm getting that it is not a fake news. In the logistic regression is also saying no. Decision tree is saying no. The gradient booster is saying no. Okay, the random forest is saying no. Again, I'm running a news and simply are getting it as a fake news, and all of them are saying a fake news. Let's say if I execute simply like a news over there, I'll take one current news. So let's say we take some news and let's see what we come up with. Basically, like, okay. Let's go over the things, if whether it is there on the web and what things are coming out to be. Let's see. Right over there, enter it. So what does say? One, the logistic regression model says it is not a fake news. The decision tree model says it is a fake news. The gradient booster says it is a fake news, and the random forest prediction says that it is not a fake news. So you are getting in there in the India today. Obviously, it's not a fake. Like if it is a fake, we can just identify it, right? So these are the things like when and how your news or things are being identified. Okay, same you can do for the images. You know that you can have to learn OpenCV for it. Okay, to identify the smoothness. You know you need to do a lot of things for the image. Sorry, the images. I have discussed for that in the computer vision part. Okay, the ANPR detection. So you can just have a review that what are the median blurs, the Gaussian blurs and all. So you can take an idea from there as well for the images and the videos. And I said there are some features to detect, right, at the images and videos and how it is going to work there. Okay. So that is from my side for this particular topic. Okay. That is the fake content detection. All right. Now, so it's your turn to identify the things. Okay. It's your turn to learn and deploy the models to make it a good idea and submit it for the deadline. Okay. So if you have any doubts relatively to this particular topic, right, the fake content detection, what you can do is you can just email and you can just give, your doubts or the questions, whatever you have, you can give it to the particular, authority, okay, and I'll be happy to guide you there, okay. So just in case of any doubts or any questions, even like you can just comment it there. I'll be happy to give you the solutions there. Okay. So good luck for this problem statement. I'll be coming up with the two other topics relatively to the uh, terrorist profiles. Okay, that are the two profiles. Two different problem statements. That is identifications of the terrorist profiles and then retrieval of the contact details of the terrorist profiles. Okay, so those two topics I'll be coming up. All right. So meanwhile, if you have any problems in this particular topic, that's I will be glad to give you the solutions for it. Okay. So good luck again. Jai Hind.